Hello guys, welcome to the third lecture of sets. In this lecture we are going to talk about algebra of sets. This is probably the most important lecture in sets primer. So this is very important in this video we shall talk about union, we shall talk about intersection, we shall talk about complement of sets, and we shall talk about De Morgan's law. So this is very important and we'll solve a very important question regarding sets. So let's get started. So the first algebra or algebraic expression that appears in set is, we call that as union. So the first we are going to learn is union. Now how a union is defined? So let's say union of A and B is defined as the set whose elements are precisely the elements of A or B or A and B, okay, or so instead of writing and B we can write or both, okay. So that's how we define union. Let's take an example to understand the definition, because in mathematics definition is generally very non-ambiguous, generally very hazy. So examples actually simpler to understand than this English statements. So let's take a set A as 1, 2, 3 and B as 1, 2, 3, 4, okay. So, or to make it more random, I can write 3, 4, 5, okay. So let's keep the number of elements same. So A union B is defined as, so A union B actually equals to B union A, and is a set that contains A which contains B. So it contains A, so it contains 1, 2 and 3. Because it also contains B, so it contains 3, 4, 5. So 3 is already here, so 4 and 5. So that's how a union is defined. To understand it with the help of a diagram, we can imagine this is set A and we can imagine that this is set B, or to make it more coherent, this is set B. Therefore A union B is defined as this. So this whole thing is union B. It contains A, it contains B, and it also contains both. Of course it will, because so that's how we define union. So this is very important. A union is actually the set that contains precisely the elements of A and B or both, okay. Now let's talk about intersection. So after studying about union, there is a remark that should be kept in mind about union. Union can be thought of as a logical connective OR. So when we say A union B, we are actually saying A or B. So a set that contains a set which contains actually, so a set which contains either A or B or both. So it is quite easier to understand this logical notion of union as to replicate union with the logical connective OR, okay. Now let's talk about intersection. So intersection, so instead of writing definition, I'm just giving an example. which would be quite easier to understand and digest. So let there is a set A, that is 1, 2 and 3, and let there set B, that is 3, 4, 5. Then A intersection B, this is symbol of intersection, that is inverted U. Intersection B is actually equals to B intersection A, okay, and that is a set that contains A and B, so the union is actually 3. So the elements that are common in both, okay. So intersection means that elements that are precisely in both the sets, and the remark would be, again here we can understand with this example that intersection is actually a logical connective. We can replicate this notion with logical connective and, okay. So when we say A intersection B, we can actually equate this is A and B, okay. So a set contains both A and B, okay. Now to represent intersection with the diagram, we can represent it with the diagram. So let us assume that there is set A, and let us assume that there is set B, okay. Then A intersection B is defined as a set that contains a common part of A and B, okay. So it will be defined as this. This is A and this is B. So A intersection B is this part, okay. So this region is A intersection B. This is A and this is B. So that's how we can represent intersection with the help of a diagram that's called actually a Venn diagram. Now we shall talk about set difference, okay. So what is a set difference? So set difference is defined for two sets, okay, and let me define it. So let A and B are two sets, then set difference is represented by this notation. A difference B is defined as the set of those elements which are in A but not in B. So that's how we define a set difference. A set difference is a set so the difference of two sets is another set which contains elements of just one particular set and not the other. So in set builder form we can represent this as, so let there be set A, so we can represent this set difference as X, and we can put some conditions that X belongs to A and X does not belong to B, okay. So that's how we can represent A set difference of A and B, okay. And let's understand with the help of an example. Let's take an example for our easy understanding. So there be a set A 1, 2 and 3, and set B, and that is again 3, 4 and 5. Then A difference B will be, so it means that set that contains elements of A but not the elements of B, okay. So 3 is a part of this guy, so A difference B will be just 1 and 2, because these are the unique elements that are just in set A and they are not in set B, okay. Now of course it can also be represented with the help of Venn diagram. So if this is set A and this is set B, then this part is actually difference of A and B. Okay, so that's how we define set difference. And of course you can put some remarks here which are very important, that difference of A and A is always phi, and difference of A and phi is A. So we can understand that the element in A but not in A is of course phi. So we are saying that let there be a set A and another set A, and we are saying we are asking to take difference of these two sets. So difference of set A with set A is actually phi, is a null set, because you are taking all the elements in A which are not in element of B. But the fact is, because both sets are same, so both sets elements are also same. And second one is difference of set A and null set is always set A, because all the elements of A and that should not be in set B. So yes, it satisfies. So these are the two very important points you can keep in mind. Okay, now we shall learn about some more properties of a set. Now we shall learn about a new property that's called the complement of set. Okay, so now let's talk about what is a complement of set. So let A be a set, let A and X be a set, be two sets. Okay, and it is given that A is a subset of X. Okay, then complement of A in X is defined as this. Okay, so elements that are in X but not in A. Okay, so we can actually define complement on the basis of set differences. Okay, so if we are asking for complement of A in set X, it means we are asking that all the elements in X which are not in A. Okay, and this is also equivalent of representing A prime, and in set builder form it can be expressed as X, whereas X belongs to X and X does not belong to A. Okay, so that's how we can define complement of set. Okay, now let's understand with it with the help of diagram. That is even, I think, more easy to understand. So let's call this is a set X and this is set A. Okay, then we are asking complement of A in set X. So it simply means that we are asking for all the elements that are in X but not in A. So complement of A in X is this, all the element in X which are not in A. Okay, so that's how we define complement. And now we shall talk about, I think this is very obvious, and a complement can be also expressed in the form of set differences. Okay, so I think that's very obvious. Now we shall talk about